This refers to a specific machine learning model from the scikit-learn library, a popular Python library for machine learning. MLPRegressor stands for Multi-Layer Perceptron Regressor, a type of artificial neural network used for predicting continuous values, like house prices in this case. It's essentially a complex function that learns to map input features, like house size and location, to an output, the predicted price. The model's predictions are consistently higher than the actual house prices. This indicates a problem where the model is overestimating the target variable. Why might this be happening? We need to find ways to improve the model's accuracy and reduce this bias. The goal is to find solutions to make the model's predictions more accurate and reliable. We want to correct the overestimation problem and improve the overall performance of the MLPRegressor model. What strategies might we employ to achieve this improved accuracy? Regularization is a technique used to prevent overfitting. Alpha is a hyperparameter that controls the strength of the regularization. By increasing alpha, we add a penalty to the model's complexity, discouraging it from learning too much from the training data and thus reducing the overestimation issue. Think of it like this. A larger alpha encourages a simpler, more generalizable model, reducing the chances of it memorizing the training data's noise. Adding more relevant features, such as property age and school district rating, can provide the model with additional information to make better predictions. This can help the model learn more accurate relationships between features and house prices, ultimately reducing overfitting and its associated overestimation. Could this make a difference? The learning rate controls how quickly the model adjusts its weights during training. A smaller learning rate makes these adjustments more gradual, potentially leading to better convergence and preventing overshooting the optimal solution. This careful adjustment can help to reduce overfitting, thereby mitigating the overestimation problem. Does this seem like a promising approach? While adding more hidden layers can sometimes improve a model's capacity, it can also make it more prone to overfitting, especially when dealing with overestimation. In this case, increasing the number of hidden layers may worsen the already present overestimation problem. Does this option seem counterintuitive in this context? The core task is to predict house prices using a machine learning model. This is a regression problem because the target variable, house price, is continuous. What are the challenges involved in accurately predicting house prices? The problem is that a house price prediction model using scikit-learn's MLPRegressor consistently overestimates prices. This means the model's predictions are too high compared to the actual house prices. We need to figure out why this is happening and how we can fix it. The model uses features like house size, number of bedrooms, and location, represented numerically, to predict house prices. The fact that it overestimates suggests a potential issue with model training or the features used. A lower learning rate means the model makes smaller adjustments to its parameters during training. This can lead to a more accurate and stable model which can reduce overestimation. It is like taking smaller steps when walking down a hill to more accurately get to the bottom. Alpha is a regularization parameter that penalizes large weights in the model. Increasing alpha makes the model simpler and less prone to overfitting. This is a common technique to prevent models from learning the noise in the training data, which can cause overestimation. Think of it as adding some weight to keep the model from becoming too complex and potentially inaccurate. Adding more relevant features, like property age and school district rating, can help the model to better capture the true relationship between features and house prices. More relevant information means the model is less likely to rely on spurious correlations and, therefore, less likely to overestimate. Hey Vamsi, this line sets the stage for our house price prediction problem. We're using a powerful machine learning model called MLPRegressor, which is a type of artificial neural network, to predict house prices. Pretty cool, huh? We're trying to improve the accuracy of these predictions. Oh, looks like our model has a problem. It's consistently overestimating the house prices. This means it's predicting prices that are way higher than they actually are. Why is this happening? Is it making wild guesses or something? This is a clue that we might be dealing with overfitting. So, what can we do to fix this overestimation? The core of this problem statement is finding the best way to improve our model's ability to accurately predict house prices. We need to avoid those inaccurate high predictions. This question wants us to identify ways to make the predictions more accurate and less likely to be too high. Increasing hidden layers in an MLPRegressor model, it's a type of neural network, means giving it more computing power, so it can consider more complex relationships. But in this case of overestimation, this might make things worse. Our model might become too complex and fit the training data too well, rather than generalizing to new data. Think of the learning rate as the model's step size while learning. A smaller learning rate means it takes smaller steps, making adjustments more carefully. This often helps the model converge to a better solution and reduces overfitting, addressing overestimation. Regularization is like adding a penalty for using overly complex models. The parameter ALPHA controls the strength of this penalty. Increasing ALPHA discourages large weights in the model, simplifying it and helping prevent overfitting and thus reducing overestimation. Adding more relevant information to our model can greatly improve its accuracy. Maybe property age or school district rating could help it predict house prices better and avoid overestimating. Hey Vamsi, this is all about improving our house price prediction model. We're aiming for more accurate predictions, not just guesses. Hey Vamsi, this is all about improving our house price prediction model. We're aiming for more accurate predictions, not just guesses. Vamsi, our model is having a problem. It's consistently overestimating house prices. This means our predictions are way too high. We need to figure out why and how to fix it. Vamsi, our model is having a problem. It's consistently overestimating house prices. This means our predictions are way too high. We need to figure out why and how to fix it. Vamsi, the core question is, how can we make our predictions more accurate and stop the overestimation? Let's explore some solutions together. We'll look at several options and see how they might help. Vamsi, the core question is, how can we make our predictions more accurate and stop the overestimation? Let's explore some solutions together. We'll look at several options and see how they might help. Adding more layers to our neural network might seem like a solution, but it could worsen the problem by making it more complex and potentially overfit the training data. Let's consider other solutions first. Adding more layers to our neural network might seem like a solution, but it could worsen the problem by making it more complex and potentially overfit the training data. Let's consider other solutions first. This is promising, Vamsi. A smaller learning rate helps our model take smaller steps towards the best solution during training, making it less prone to overshooting and therefore overestimating. This is a good approach to refine our results. This is promising, Vamsi. A smaller learning rate helps our model take smaller steps towards the best solution during training, making it less prone to overshooting and therefore overestimating. This is a good approach to refine our results. This is also a great idea. Regularization, with the alpha parameter, penalizes very large weights in our model. This makes it less likely to fit the training data too perfectly, overfitting, thus reducing overestimation. Alpha is a control parameter for L2 regularization. This is also a great idea. Regularization, with the alpha parameter, penalizes very large weights in our model. This makes it less likely to fit the training data too perfectly, overfitting, thus reducing overestimation. Alpha is a control parameter for L2 regularization. Adding more features, like property age or school district ratings, could help our model understand house prices better. More data can help our model avoid overfitting and make it more accurate. Adding more features, like property age or school district ratings, could help our model understand house prices better. More data can help our model avoid overfitting and make it more accurate. The problem statement introduces a scenario where a scikit-learn's MLPRegressor model, used for predicting house prices, consistently overestimates the actual prices. This suggests a potential issue with the model's performance and accuracy. We need to investigate ways to correct this overestimation. Let's dive in. This line describes the core issue. The model's predictions are systematically too high. It sets the stage for exploring solutions to fix this problem. The goal is to make the model's predictions more accurate and reliable. What strategies can we use? This is the central question of the quiz. It asks to identify actions, from a multiple-choice list, that will likely improve the model's accuracy and reduce the overestimation bias. We are looking for solutions to resolve the model's bias in the output. Let's analyze each option. This option suggests increasing the complexity of the neural network. Adding more hidden layers can improve the model's capacity, but in the context of overestimation, potentially due to overfitting, this could worsen the problem, leading to even more complex and inaccurate estimations. What do you think about this? This involves reducing the step size taken during model training. A smaller learning rate helps to make more precise adjustments in the model's parameters, leading to improved convergence and potentially reducing overfitting, a common cause of overestimation. Let's consider this option carefully. Regularization, often using L2 regularization, controlled by the parameter alpha, adds a penalty for large weights in the model. Increasing alpha penalizes complex models, discouraging overfitting and improving generalization ability, all contributing to more accurate and less overestimated predictions. This approach should be considered. Adding relevant features such as property age or school district rating to the dataset can provide more information, helping the model capture the underlying patterns in the data more accurately and potentially reducing overfitting and overestimation. Isn't that a good idea? This is the title of the problem we're tackling. We're using a machine learning model to predict house prices, and we're trying to improve its accuracy. Specifically, the current model is overestimating the prices, a common problem in machine learning that we need to address. Think of it like this. Imagine you're trying to predict the height of sunflowers using a model. If the model always predicts them to be taller than they actually are, we have a problem. That's what we need to fix here. The core issue is that the model consistently predicts house prices that are much higher than the actual prices. This isn't a minor issue, it's a significant problem that affects the reliability and usability of the model. Imagine trying to buy a house based on these predictions. You'd likely be severely misled. This is the main question of the quiz. We need to identify the strategies that can help us improve our model and make its predictions more accurate by reducing the overestimation. We're not just looking for any improvement, but specifically improvements that address the overestimation problem. Think of it like diagnosing a patient. We need to find the right treatment to fix the specific issue. Adding more hidden layers in a neural network, MLPRegressor uses a neural network structure, increases the model's complexity. While this could potentially improve accuracy, it also risks increasing overfitting, meaning the model learns the training data too well and performs poorly on unseen data, possibly even worsening the overestimation problem. It's like trying to solve a simple puzzle with a massive, overly complicated tool. You might end up making things worse. The learning rate determines how quickly the model adjusts its parameters during training. A smaller learning rate makes the adjustments more gradual and precise, potentially helping the model converge to a better solution and reducing overfitting. Think of it as fine-tuning a machine. Smaller adjustments lead to better precision in a more refined end product, possibly avoiding overestimation. Regularization, specifically, L2 regularization in this case, controlled by the alpha parameter, penalizes large weights in the model. Larger weights often indicate overfitting. By increasing alpha, we discourage the model from having excessively large weights, making it simpler and less prone to overfitting, thus reducing overestimation. It's like adding a penalty for excessive complexity, forcing the model to find a simpler, and hopefully better, solution. Adding more relevant features to the dataset provides the model with more information to learn from. This can improve the model's accuracy and reduce its reliance on noisy or irrelevant data, which often leads to overfitting and overestimation. Think of it as giving the model more context. More details often lead to a better understanding and improved predictive accuracy.